My objective at the beginning of class was for you guys to try to find the angle menu. So what'd you find? Where'd you go? Second, apps. Yep, there's that angle menu. And what do you see? You see the degree mark. You see the, okay, ready? This is called the minute mark. So you might up here next to minutes, underneath, you might want to put a little single hash, a single apostrophe. The minute mark is going to be only one dash. And then, what else was, there wasn't just minutes, there was also seconds. I mean, I'm guessing, right? Because we know degrees is that one. We know minutes is that one. So you can go ahead and write down the quotation mark or the double quote. That's going to be seconds. So we have degree, we have minute, we have seconds, but it's not there. Oh, degrees. Ah, minutes. Seconds. Oh. So some of you guys are maybe playing over here, and you're like, okay, well, I think I need the 13, and then the second apps, degrees. Okay, we got that. And then we can do the 2, and then we can go to second apps, and then we can do minutes. Oh, I did the wrong one. There we go. And some of you might have been like, well, let me see if I can figure out the pattern, because then maybe, or you might have tried that R thing. Yeah, it wouldn't have worked. E for effort. 13.0333. What is that? 13 and a little bit more. That's 2 little bit more. I wonder what that is. 2 over 10? No, that's 0.2. 2 over 20? No, that's 0.1. 2 over 60. I wonder what 2 over 60. Oh, hey. 60. Why did I think 60? Minutes. 60 minutes in an hour. And then seconds, 60 seconds in a minute. So really quickly, up here in your notes, we're going to get back to our calculator in just 1 second. And that was just for 13 degrees, 2 minutes. We might have to figure out that second thing in a second. 1 degree is equal to 60 minutes. Sorry. Man. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. 1 second, well, I guess we could do 1 second is equal to 1/60th of a minute, which is equal to 1, wait a minute. Close, not 3/60th. Not 1300. 3600. 1/3600th of a degree. Why on earth would they want to split 1 degree into a second? Into seconds. 3600, oh hey, we could fill this in, right? 3600 seconds is 1 degree. You could think of even building bridges if you really wanted, because we could go ahead and say, okay, 1 degree times. And we could say there are 60 minutes in 1 degree. And we could say there are 60 seconds in 1 minute, right? So that's how we could get 3600. We could build bridges. So there are 36 seconds in 1 minute, or sorry, 3600 seconds in 1 minute. I guess what could we do here? 1 minute is 1/60th of a degree. Hey guys, how big is a degree again? Oh, yeah, 1/360th of a circle. How big is 1 degree? It's not very big. True? For me to measure a 1 degree angle, wouldn't I have to just like go up? Wait, it's not going. Hold on. Why isn't it going? Oh, it starts over here. I forgot. There we go. That's 1 degree. They split this into 3,600 pieces? This protractor, this half circle is cut into 180 pieces, right? 180 pieces. Why on earth would they ever think that we need to take 1 degree and split it into 3,600 pieces? Can you even imagine that? This little space, 3,600 pieces. Why? This half circle is 180 pieces. If I put it all together, 1 full circle is 360 pieces, and that's how you get a degree. 2 degrees, 3 degrees. Each of those add up to be 90, or add up to be 180, or add up to be 270, or 360, or anything in between. Why on earth would they ever take 1 degree? And they can't even look. They can't even show the 1 degree properly. Like, it's a lot easier if you do something like, I don't know, 30 degrees or 46 degrees, whatever I just did. they can't even, I don't know. The degree mark should be up there. Anyway, long story short, 1 degree split into 3,600 pieces. How much space was there way back here at the very beginning of the degree? Barely any. But what's going on as you proceed outwards? Can anybody think of anything that has degrees measured that's a lot bigger than even that? What are degrees used to measure besides angles in math class? Temperature, okay. But think about temperature. Like, do you think you could really feel the difference between 76 degrees and 76 and 3,600th of a degree? Not really. I mean, I'm not saying that in some like experiments, et cetera, you need the temperature to be very precise, but that still seems a little crazy as far as 76 and 1/3,600th of a degree. What else are degrees used to measure? Like actual size of things or location of altitude. What do you mean the altitude? There you go. Tony was trying to think of the words. Longitude and latitude. Wait, what do longitudes and latitudes measure? Location on the Earth. How big is the Earth? Okay. But wait a minute. If you're standing at the North Pole and looking down, and you are on the very center of the top of the Earth, right? If you turn in one circle, isn't that just 360 degrees? But what happens with latitudes and longitudes? It starts from a point and it proceeds the entire globe. And then it comes back. So when you're standing on the North Pole, how big is 1 degree? Right? But if you were to have 2 people walking, or even like an instrumentation to go ahead and start going out, down and around the entire Earth, how big is that 1 degree going to get? A lot bigger than that. True? So if you're stuck in the middle of the ocean somewhere, theoretically, and if you want someone to come find you, and there are sharks, and you don't have a boat, okay, you want someone to find you fast, do you want to tell them, oh, I'm on this degree somewhere? No. You want to tell them exactly where you are so they come get you now. True? How do you do that? You need minutes and seconds to be more precise. So if we're just measuring angles in math class, what's the practicality of this? Not at all. Would you be able to tell the difference between a 1 degree and a 1 degree and 2 seconds? No. 1 degree is hard enough between like 2 degrees, 3 degrees, 45 we know, 90 we know, 135, 180, 30, 60. We know the difference between like big jumps but little jumps and make the jumps even smaller. But for GPS and navigation, we need, oh, wrong way. For GPS and navigation, degrees are not precise enough because it's measuring to some degree based on latitudes and longitudes. In order to pinpoint an exact location, 360 degrees, 360 partitions as far as longitudes or even latitudes, it's not very much. Meaning a lot of space gets covered in every 1 degree. Just to give you an idea as to why we might ever want to split up a degree into something smaller, it's because of navigation, it's because of the size of our Earth and how 360 partitions, that's still a lot of space that's being covered. So here's the dealio. Think dimensional analysis. If we want to convert to decimals, at the end of the day, we're trying to think of what would this guy be as, what would this guy be just with degrees? We would go ahead and say, well, you know what? We already have 13 degrees, so that's not a big deal. I'm actually worried about. Yeah, so the 13 degrees, that's our forget him, but we need to go ahead and convert the 2 minutes and convert the 10 seconds building bridges. So we can go ahead and convert the minutes to degrees by saying, aren't there 60 minutes in 1 degree? Wait, why did I build the bridge that way? I put what I don't want on the bottom so that it will reduce. And that would end up being 2 over 60, which is 1 over 30, right? So I can say that 2 minutes is the same thing as 1/30th of a degree. What can I do with seconds? Yeah, I have an option. I could do something like, hey, there are 60 seconds in a minute. Wouldn't you have to keep on going and say there are 60 minutes in a degree? So an easier way of doing it might just be the other conversion of, I think Vico and Kyle both said it. How many seconds are in? Yeah, 3,600. So then wouldn't that be 1 over 360th of a degree? So then how could I get to decimals from that? Don't both of these pieces need to be in? I have to say, okay, I have 13 plus 1/30th plus 1/3600th. And get denominators if that's a helpful thing. 30 into 3,600, wouldn't that be times what, 120? Do you guys agree? 12, but I need with an extra 0. So then that would end up being 13 and 1/20th over 3,600. Oh no, 1/21st, sorry, I can't add. Struggle. Ugh. Do you see how if you had instruments that measured minutes and seconds, that'd be a lot more efficient than trying to split 1 degree into 3,600 pieces and then count 121? Adam, go ahead.
So in the top, like for the 10 seconds, you went into 1 over 360, but then on the bottom, you turned it into...
Oh, thank you, thank you, thank you. I totally just rewrote it wrong, didn't I? So I don't need 120, don't I just need 12? Nice, that makes life a little bit easier. So then that'd be 13 and 13 3/60ths. But the idea is with instrumentation, it'd be a lot easier if we could measure minutes and seconds as opposed to having to think about 13 3/60ths of a degree. Right? And if we were to get the decimal, we could go ahead and do a long division. If you guys remember, put 0.0000 and divide in. We could do long division just to save on time. We will go ahead and, hold on, remember that was only 13 minutes, 13 degrees, 2 minutes. We still haven't figured out how to do seconds. Once again, you could try in that cool menu that you guys found. You could try the R, but it doesn't work, at least not to do what you think it's going to do. So let's go ahead and figure out what the answer should be. The answer should be 13 and 13 3/60ths. So here's what the answer should be. It should be pretty close to what we found, but it's a little bit different, a little bit off as far as we hadn't done or accounted for the seconds. So it's going to be 13.0361. Oh, sorry, I just did a 1 repeating. Has anybody figured out where the double quotes are on the calculator? Sometimes the calculator won't make a brand new function if there's already something somewhere else. Can anybody find the double quotes anywhere? Here's the 13 degrees, number 1. Here's the 2 minutes. I'm looking for the double quotes. Anybody find them? It's not in the angle menu, P.S. It was somewhere else. Double quotes. Isn't that like a character on your keyboard? Keyboard. A, B, C, D, E, F, G. Oh, hey! Alpha plus. Nice. Super awkward, huh? You guys know that second over gets you to the end of the line. Maybe. Sorry, alpha plus. Yep, there's a little double quotes. Dun, 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 dun. So how do you do it by hand? You think of dimensional analysis and building bridges. To get 13 and 13 3/60ths of a degree, aka 13.036111. With your calculator, you can actually get degrees and minutes and seconds. However, if they were to give you a decimal, hey look, 14.326, let's see what the answer should be. 14.326. Did anybody figure out, or reading those directions, have you seen something that you think might help us change from decimal to degrees, minutes, seconds? Where is it? Second angle. Hey, number 4 says arrow, go to DMS, go to degrees, minutes, seconds. Oh, look. Dun, 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 dun. Oh, there's a 0.6 of a second? Sure, why not? I don't know. But yeah, it'd be 14 degrees, 19 minutes, 33.6 seconds. So how could we do that by hand? Interesting. Some of you might be like, there's something that can do it for me. Why on earth are you always showing me how to do it by hand? Pause. Do you think maybe someday I'd rather you guys be making the instruments and making the programming than just following and using the instruments and using the programming? If you're in honors pre-cal, maybe it's something where you could be doing the programming one day. And maybe for problems that haven't even been programmed or instruments that haven't even been made yet. You always have to think behind the scenes of how to get where you're going if you want to ever think about doing the programming yourself. Anyway, so yeah, there's a cool calculator program, but where did it come from? What math is it doing behind the scenes? Well, if this is degrees, I apologize, should be a degree mark, and I'm trying to convert to DMS, isn't the 14 already okay? What's not okay? How could I convert that to be minutes? 1 degree is how many minutes? Oh. So I could do my 0.326 times 60. I think I'd rather have the 60 on bottom. There we go. So that'd be double checking. Sorry. Leave the place, right, for the 0. 6 and 6 is 36. Carry the 3. 12 and 3 is 15. Carry the 1. And 18 and 1 is 19. Okay, so can't I right away with that little quick multiplication, can't I now say the degrees are canceled out? That's minutes, right? 19 minutes. But don't I have another category still to go? Okay, so what's left over? 0.56 minutes can now become 60 seconds, right? Jason, stand up in the back of the room. That's your last chance. 0.56, I can go ahead and multiply by 60. 6 and 3. Aha. Isn't that what your calculator told you? Yeah, there's not a small unit per seconds as far as measuring degrees. Okay, have we learned how to use our calculator a little bit more for angles today? Hopefully. Do you guys have any questions on the calculator way of doing it? Where's that cool little angle menu that we were using? Second, apps. Where's the second mark again? Alpha plus, good. And then the DMS takes us from a decimal, 2 degrees, minutes, seconds. Degrees, minutes, seconds can go to a decimal just by hitting enter. And then by hand, did we use some bridges? Yeah, I think so. Cool, kids, that brings us to homework 23. I'm not going to go through all the evens and have us grade, et cetera, et cetera, et cetera. But I will offer to do 1 or 2 hints as far as places you got stuck. So is there any place you want me to go? We're okay? 76, is that a problem? Okay, I can do a little hint. Just a little, oops, too far. Ah, the key is not degree or radian, the key is How many degrees are they having you compare? Radians. Okay, 1 degree, didn't we just look at it on the screen? Okay, 1 radian. Radians, what do I want you to think? Flexible rulers of radiuses. So take any circular object. What's the one I did the other day? This one, right? I'll take this. I'm not turning it upside down. Okay? This is radius. Ish. True? Okay. It's radiuses measured around the circle. So couldn't I, here's a nice little x-axis, and we always start on this side and measure up, right? So couldn't I take that ruler? Where does that hit? I don't know, about 45? Does that make sense? So 1 radian is 1 radius measured around. It's about 45. Couldn't I take 1 radian and convert it if you guys wanted me to? What would 1 radian converted be? What bridge would I multiply it by? Yeah, 1 radian would be times pi and 180. 180 over pi. Isn't pi approximately 3? So wouldn't that be approximately 60 but a little bit less? 180 divided by 3. 60 but a little bit less. Who's bigger? 60-ish but a little bit less, or 1? 60. Does that make sense? But tricky, right? They didn't say 1 degree, 1 radian. They said a degree or a radian. A degree is tiny unless you're going around the world and measuring the entire Earth with degrees, with longitudes, latitudes. But as far as just general measurement of a circle, radian wins every single time. Does that make sense? Anything else you want to talk about real quick? Going once, going twice, sold. Okay. Does that help you guys with degrees, minutes, seconds at least? Cool. Let's go ahead in section 4.2. The reason why I thought we'd keep going is because we had a little bit of notes to catch up on. And section 4.2, I haven't written it on the board. I have my calendar open to make sure it's keeping me honest. That homework is due until Thursday. So that way we kind of have beginning of class tomorrow. We can check 4.1. All right? So if you do need to finish up something else, go ahead. And remember, according to the comment in Google Classroom, I'm giving grace on those degrees, minute, second ones as far as you guys didn't need to attempt them. Section 4.2. Let's go, team. Let's go. Let's go, team. Let's go. Whoop. Struggle. Rachel, can I have you pass one of these out to everybody? It's up to you. You can just do every person, or you can pass down the rows. Where's my other cup? You guys make one for Aiden too, if you have time. You guys ready for our unit circle party? Yep. Remember how I was talking about how I need your brains to think in radians and not degrees? Eventually, maybe not perfectly right now, but eventually. This is to that end. Radians are just fractional. Well, radians are radiuses measured around flexible ruler, right? That's what radians are, ultimately. Having to do with the size of the circle and measuring around the circumference. But as far as ancient are calzones. Are calzones. What's a calzone again? Folded pizza. I'm going to freeze the screen and try to get a picture of calzone, because for those of you poor souls that have not tried one, at least not tried one that's made well, you might have no idea what we're talking about. Where's my remote? It's way up here. P.S. Remember, math homework, try a calzone. It's not for a grade. It's not for a grade. Hey! That could be fun, though. I could make an extra credit assignment, and you can, like, send me a picture. That'd be kind of sad, though, because some of you, it's harder to get calzones than others. We'll think about it. Of you enjoying a calzone and being like, look, it's pie! Anyway, back to the circle. Points on the unit circle. Trigonometric ratios. We'll talk more about this as we go on. But the radius is 1. Wait, if the radius is 1, then hold on. Can't I mark this? What would this point be, guys? Well, that'd be 1 unit, right? So wouldn't this be the point 1, 0? What would this point be up here? 1 out, 0, 1. What would this point be? Negative 1, 0. And what would this point be? Can you please also label your coordinates? So we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Also label your coordinates. Robbie, where's your patty paper? Got to be labeling them, huh? There you go. Going out 1. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But guys, those aren't the only pieces of our unit circle, right? I'm seeing if I have one already done. Don't we have some other partitions of a unit circle that are pretty important besides just 0 and pi over 2 and 3 pi? Sorry, pi over 2, 1/2 calzone, 1 whole calzone pi, 1/2 3 pi over 2, and then 2 pi. We have some other important ones if you guys remember your unit circle from last year. Do you remember what angles those are? In degrees? 30, 45, 60, etc. So here's what I want you guys to do. In order to build up to that, let me bring this guy up. Okay? I want us to take our patty papers, and I want us to try to go ahead and get 45s. Now, let's talk about this. 45s. How does a 45-degree angle occur? What would he be half of? He'd be half of 90. So if we're trying to use folds to do this, how could you guys get 45 degrees very precisely with a fold? Yeah. Couldn't you fold this guy back into your 90 degrees? True? Couldn't you say, hey, I need 90 degrees? Ooh, we'll see how close we were. I was a little bit off on mine. Oh, they don't meet. That's okay. Can't you take your, shouldn't the center be right here? You guys have it all marked? Here's my center. Can't you take your 90 degrees and just fold them in half? What's going to happen if I'm all the way down to one quadrant, if I take and fold that 90 degrees in half? Pause. Wasn't this half a calzone, true or false? This is half a calzone, right? Pi over 2. What happens if you fold that pi over 2, or 1/2 a calzone? What happens if you take half of him? It becomes a quarter. Unfold, only 1 calzone. Unfold, only 1 calzone. Only 1 pi. How many pieces is he cut up into? Your fold, how many pieces? 4, right? Go ahead and trace those lines for me. Because we've just divided this guy into, we have our 0 already. We have 1/4 pi, we have 2/4 pi. You guys already have him labeled. 2/4 is 1/2. You have 3/4 pi, and you have 4/4 pi. Can you keep counting by fourths to finish off the rest of them all the way around? Trace your 45-degree angle marks, aka your half of a pi over 2. You've now cut the entire, each calzone, each pi, into quarters. So count by 1/4. So 1/4, 2/4 already marked, 3/4, 4/4 already marked. What would the next one be? Let me give you guys a second. Let me trace my lines too. If you have a straight edge and index, mine's nice and pretty. Just count by fourths. Start at your 0 and go up. That's 1/4 of a calzone. 1/4. 2/4 already have it. It's a half. 3/4. Oh, there he is. 4/4. 5/4. 6/4. 7/4. 8/4 is all the way back to 2 pi, isn't it? Because if you have 8 pieces, you have 2 full ones. Now, are there degree equivalents to these? Yeah, there are. 45, 90, 135, 180, add 45. 225, add 45. 270, add 45. 315, But actually, to be honest, I like radians better because all I have to do is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Yay, back to 2 pi. It's just counting by fractional calzones. Yeah? Now, are there coordinates that go along with these guys too? Yeah, there are. We could go back to geometry. We probably will another day. You guys already have these ones already marked as far as 0. Sorry, not 0, 1. 1, 0, over 1, up 0. You already have 1, 0 marked, and you have 0, negative 1 marked. And you have negative 1, 0. Negative 1. Did I put a negative in the positive spot? That's awkward. This is something in between 1 and 0. What is this something? Geometry would tell us that for a 45 degree, we're going to go over and up square root of 2 over 2. And we'll see another day as to why. But what's going to change in the second quadrant when I go left and up to the point? Yeah, the units don't change as far as the actual measurement or the distance, the magnitude, but the x is going to be a negative and the y is going to be a positive, true? To go to the left and up? Or to go to the left and down? Uh-oh, left and down. What's this guy going to be? Negative root 2, negative root 2, because the x and y are both negative going back to chapter 1 or algebra 1. And then this guy is going to be to the right and then down, hence positive root 2 over 2, negative root 2 over 2. But guys, those aren't the only special unit circle ones. What's the last one? 30s and 60s. Now here's the trick. 30s and 60s, and we're going to have to finish this one tomorrow and finish the section, but that's okay. That's why I'd take 2 sections. Aiden, if you're done, just on my desk is good. Don't I need to split 90 degrees into thirds? Oh. Here's the long story short. You're going to want to take one side of your 90 degrees and go a little bit past the 45. A little bit past the 45. Not a lot, but a little bit past. To where these two look equal. You're going to want to go a little bit past the 45 until they look equal. Until these two look equal. Go a little bit past the 45 until they look equal. There should only be 2 showing though. Go ahead and fold. And if you did it right, you did a trifold, you can come back. And then you should have approximately, if you were to unfold it, a third of 90, which is 6 pieces of your pi. And we're going to go ahead and label our pi over 6's 2 pi over 6, which is pi over 3. 3 pi over 6, 4 pi over 6, 5 pi over 6 is tomorrow. Lose your patty papers. Put them safely into your book. This homework isn't due until Thursday. And once again, if you're doing your last fold, take one side a little bit past the 45 until they look about equal. Fold it back in. And then go ahead and say, ooh, tuck that in somewhere safe, and we'll get back to it tomorrow. Bye, cool kids. I'll see you later. I'm going to go ahead and get this set up so that we're ready for tomorrow. Yeah. What's it for? USC? Okay. After what? Oh, I know, I'm sorry, me too. That's weird. Huh. See you, buddy.
Hi, Mrs. Steve.
Hi, Joe. Mm-hmm.
Are we going to learn it today?
No. No, honors is learning it. Remember, they're a little bit ahead of us.
Oh, yeah, sure. I think this is fun.
I agree.
It's not that hard, but
It's not that hard, but depending on your brain, it can be tricky.
Are we doing that?
I already remember it actually.
No, this is for honors. Sorry, I'm finishing up from their class.